Hello everyone, welcome to the RCNP course. Now we are going to introduce the topic, which is the IGMP principles. About the IGMP, first let's take an overview of it. A multicast network. The multicast receivers need to join a multicast group, and routers need to manage and maintain the multicast group. Because for a multicast package, if you check the destination IP you can find, it's a multicast address. And a multicast address represents a group of receivers. So we should manage these members in each group. And to prevent layer broadcasting, layer 2 switches on the network need to obtain information about multicast groups and the multicast group members on the network segments. So about these parts, to manage the members in each group, what we use is the IGMP. IGMP stands for Internet Group Management Protocol. It's a protocol used to exchange information between hosts and routers. All hosts to be added to a multicast group, and all routers connected to a subnet with a multicast host must run IGMP. So from here, you can know that IGMP is running on routers, and the function is to help routers manage all the members in each group. IGMP messages cannot be forwarded by routers. Cannot be forwarded by routers means that once a router receives an ICMP message, it cannot forward it to maybe another network segment. This is why we say that they are restricted to the local network segment. And the TTL value of IGMP packet is always 1. As we know that the TTL value is a field in the IP header, right, which is used to limit the number of hops that a packet could be processed by a layer 3 device. So if the TTL value is 1, means that it can only be forwarded by a layer 3 device for only once. In this case, we can ensure the application range of the IGMP. And with the development of IGMP, it has 3 versions. IGMP version 1, 2, and 3. Of course, there are some difference between them. Later, you will know this. And all IGMP versions support the ASM model, any source multicast. We have mentioned it in the instruction of multicast. ASM represents that there's no requirement of the source of the multicast packets. And IGMP version 3 can be directly applied to the source-specific multicast. We call it SSM model. Let's see the working mechanism of IGMP. Now we have 2 routers, router A, router B, and we have 3 hosts, host A, B, C, which are the client of different multicast services, right? So firstly, in this network, first is the carrier election mechanism. Which is a carrier? Firstly, you should know the definition of carrier. Actually, when we use IGMP, carrier represents the routers, router A, router B, because for these routers, they should send the carrier message to the hosts to ask for which group you prefer. Right? So routers are the carriers. But if we have multiple routers connect to the same network segment, for example, here, router A and router B, so we should do a carrier election because only one carrier is needed in one network segment. And the next is the maintenance of multicast group by routers, right? Because routers should maintain a list or should maintain a table. And in this table, you can find the receivers and the source they prefer. As you can see in this figure, for the routers, they will send the carrier message to the hosts to ask each host that which group you prefer. But after the query election, only one router will send it. So for example, since router A is a query in this case, so only router A will send the query message. And after receiving the query message, each host will send a report. You can see the report is actually the response to the query, because for example, router A is asking host A that which group you prefer. So host A, by sending the report message, will tell the router that, okay, for example, I prefer the package from group 1 or group 2 or group 3. Right? Of course, there could be a multicast IP address representing the group. And next is a leave message. Leave message means if I have joined one specific group, means I want to receive the package from this group. But for some reason, maybe I don't want them anymore, so I will send a leave message to tell the router that, okay, I don't need this package anymore. You don't need to send it to me. Okay, this is the leave message. And for the hosts in the same group, because from the color here, you can see host A and host B are asking for the package from the same group, but actually it's not necessary. The function of IGMP is to help router A or to help routers know which kind of package or which group's packets are necessary in this network segment. So after receiving the report from host A, router A has already known that the package or the traffic from maybe group 1 is necessary. So router A will send the package to this network segment. No matter is there any reports of the same group from another host. So in this case, host B don't need to send the report again. This is called report separation mechanism. In this way, we can reduce the control messages in the network segment to maybe improve the efficiency, right? Okay, after knowing the basic working principle of IGMP, next, let's see the detailed information. Firstly, is the IGMP version 2. Let's see it. A router sends a general query package. General query is the query message which is sent periodically to the receivers in the network, right? And the destination of the general query message is special. You can see it's destined for 224.0.0.1. This multicast address represents all user hosts. And in this way, the router can find out the multicast group members existing on the directly connected network segments. And after receiving the general query, a user host sends a membership report to the multicast device to specify the multicast group that the user host wishes to join and receive multicast data from. So host A will send a report. In this report, it contains actually IP address 230.1.1.1. It represents that host A says, I prefer or I want the multicast message, multicast packets from this group, and it will be sent to the router. Okay, this is the general query and report. And for host B, if it's, you can see, if it's asking for this package from the same group, it will, it's not necessary anymore. Right? So host B don't need to send it. But for host C, since it's asking for the package from another group, so host A should send another report. This is the general query and the membership report. After receiving these reports from hosts on the router, it will generate a multicast group information table, you can see. And for this entry, you should, the first part actually should be the source, and the second part is the group. So we call it SG group entry. But since here, this is the ASM model, so we don't need to specify which source we need. So here we use the mark. We use a mark to represent. Means we don't need to specify which source we need. Okay, and next, let's see the separation mechanism. When the host receives a membership report from another host in the CM subnet, the host no longer sends a member relationship report to the CM multicast group, because the IGMP router already knows that the host in the local subnet wishes to join the multicast group. Because if you can think about it, for the router, if it receives only one receiver's report, maybe for a specific multicast group, it will forward the multicast package to the subnet. Even it have maybe 2 or even more receivers of one specific group in this subnet, it will also only send maybe the package from this group to the subnet. It will not affect the result, so we don't need each receiver to send one specific report message. This mechanism helps reduce information traffic of the local subnet. It's very useful. And next is the leaf group and the group specific query. Let's see, this is another scenario. Now, a user host sends a leaf group message testing for 224.0.0.2. This is also a special multicast address. It represents the router. Okay, it represents the router. And the leave group message is used to notify the local router that the user host is to leave the multicast group. Maybe I will switch to another group, or I don't need to receive them anymore. So I will send a leave message. For example, host A send a leave message. After receiving the leave message, since host A wants to leave the group, but in the subnet, there could be other receivers of this group. So the router needs to ensure this. So the router sends a group specific query, and the destination address is 230.1.1.1. Actually, this is the IP address of the group. Right? This is the multicast address of the group to figure out whether the multicast group still has members. In this case, if host B and host C, if both host B and host C don't need the package from this group, so there will not be any response anymore, right? But if there is still other receivers, for example, if a multicast router fails to receive a membership report in 3 query intervals, so it will log the traffic of this group. But in this case, since host B still need the package from this group, so host B will send another report says, yes, I'm the receiver of this group. So router A, after receiving that, router A will still forward the package from this group to the subnet normally. And for host C is different. Since there is for the group 230.2.2.2, there is only one receiver, which is host C. If host C leaves this group, router A will send another group specific query to ask, is there any other receivers of this group? Since there is no response, right, obviously we can figure out from this figure. So router A will not forward the package from this group to this subnet and anymore, right? And you can see the multicast group information has changed, right? The entry which is mapped to the group 230.2.2.2 is deleted from the multicast group information. Okay, this is the group specific query and the leave. And next is about the carrier election. We say that if we have multiple routers connected to the CM network segment, only one router needs to send the general query message. So there would be a query election. Let's say this. When the query receives a query from a router and find that the router has a smaller IP address, the query becomes a non-querier. Means that now we have two routers, router A and router B. And at the initiate stage, both of them think they're the querier. So router A will send the general query, router B will send the general query. And of course, they will receive the general query from each other. And after receiving the general query message from each other, router A and router B will both find out that there is another router in this subnet. So they will do the election based on the source IP address of this query message. And after comparing the IP address, since we prefer the router with a smaller IP address, so in this case, since router A has a smaller IP, so router A is a querier. Right? If a non-querier does not receive the general query packet for the querier within specified time, the query election starts again. It means that now router A is a querier, but if router A is faulty, it will not send the general query message periodically. So router A will not receive the general query message again. It will wait for twice the query interval. And after twice the query interval, they will start the query election again, and router B will be the querier. And it will actually is a kind of backup, right? It's a kind of backup. This is a query election, and you can see the IGMP packets. All the messages have their format, so you can see this is a structure of a IGMP packet. It contains some fields: type, max response time, checksum, group address. The membership reports is type value is OX16, and leave group message type value or general query type value, group specific query type value is showing here. It's fixed. Okay, different value of the type field reference different types of IGMP packets. And for the max response time, the default value is 10 seconds. And it's only take effect at the general query packets to control the limitation of time that the receivers respond to the query message. And checksum, as you know, is used to verify. And group address represents the multicast address, actually. And for some special messaging, for example, general query message, the group address is 0.0.0.0, and destination address is 224.0.0.1. Group specific query, group address and destination address are the address of the specific group. And the membership reports, the group address, destination address are the address of the multicast group that need to report information to router. And the IGMP version 2 leave message, it's the group address is the address of the multicast group that the host is to leave. Destination address 224.0.0.2. Of course, we see that it represents the router and the router in the subnet. Okay, this is the structure of the IGMP package. And after knowing IGMP version 2, next let's see IGMP version 3. And different from IP version, different from IGMP version 2, IGMP version 3 has an additional function support for multicast source filtering. An IGMP version 3 host can select to receive data from a certain multicast group and select to receiver or reject multicast data sent from certain multicast source to the multicast group. It defines a new packet type and the format. The destination multicast address of IP version 3 is changed. is changed to 224.0.0.22. And the IGMP version 3 discards the membership report separation mechanism, because if we use the report separation mechanism, if the receiver received the report packet from another receiver in the same group, it will not send the report message anymore. But in IGMP version 3, it's possible that for these two routers, it's possible that for the two receivers in the same group, they prefer the package from different source. Okay, so we discard the report separation mechanism. And the next, let's see some user host actions. When IGMP version 3 host maintains an entry for each multicast group on the interfaces in the following formats: group address, filter mode, source list. Okay, and the filter group address is quite easy to understand. It's the IP address of a specific group. And the filter modes could be two types: include and exclude. In the include mode, only multicast packets sent from multicast sources listed in the source list are received. For example, include two group address, so means we want to receive the multicast packets from these two groups. But if it's exclude means that only multicast packets sent from multicast sources not listed in the source list are received. The source list contains no or multiple IP unicast addresses and is usually represented as a collection. If pay attention here, if it contains no group address, represents that I don't want to receive the multicast address. I don't want to receive the multicast package. Okay, it's a kind of leaf message. And for the group records, there could be some possible scenarios. For example, ECIN indicates that the multicast source filter mode is included, and only the packets sent from a specific multicast source to the multicast group are received. Is X means exclude. It's easy to understand. To in or to exclude means we are switching from exclude to include or from include to exclude. Okay. And for allow indicates that multicast packets sent from specified multicast source to the multicast group are allowed based on the original filter mode. And the original filter mode would be include or exclude, right? And for block indicates that multicast packets sent from specified multicast sources sent to the multicast group are not received based on the original filter mode. And as we said, the original filter mode could be include or exclude. Okay. So after knowing after knowing this, next let's see some cases. Routers maintain one state for each multicast group on the interface, and the state consists of group filter mode, source list, and the timer. Group state is in this format: group address, group timer, filter mode, source report list. Each source report is in source address and the source timer. So we use this kind of parameters to ensure the multicast forwarding in the network. And each multicast group uses only one filter mode. We can use an include mode or in exclude mode. And let's see a case. After seeing this case, I think it can help you have a deep understanding of this. Now we have a router and three hosts. And firstly, the router will send a general query message to ask each host in the network that which multicast packets you like. And then host A will send a record, says that I want the multicast group packet 228.1.1.1. And is X means I can receive the multicast packets from any source except 222.3. Okay. Of course, is x means exclude, right? And for host 3, it says that I want the multicast packets from the group 228.1.1.1, and the source could be any source exclude 2.2.2.1. So in this case, on the router, it will generate multicast group information. The group is 228.1.1.1. Filter mode is exclude. Exclude what? Exclude the packets from these two sources, 222.1 to 222.3. Okay, and for the host B, it will send a report 228.1.1.2 means I want to receive the multicast package from this group. And the filter mode is in. In means include. I want to receive the package from this group. And the source could be 2222 or 2224. So on the router, it will generate another entry, right? Different from the other one. Here is include these two sources. Okay, this is the general query. And after generating these two multicast group information, now in this case, host B reports now group is 228.1.1.2, block 2.2.2.2 means now host B says that, okay, I want to receive the packet from this group 228.1.1.2. Block means I don't want to receive them from the source 2.2.2.2. So in the multicast group information, the source 2.2.2.2 should be confirmed because I need to ask for other receivers. Is there any other receivers want to receive the packets from group, right? From this group 228.1.1.2 and from the source 2.2.2.2, right? If there is, I will keep this entry in the multicast group information. But if there's no reply, so I will delete. And obviously in this figure, there is no requirements. So this entry will be deleted in the multicast group information. So after this, you can see the multicast group information has changed to this state. And in this case, host B sent another report, says G228.1.1.2 means for this group, two in means I want to switch to include. Include what? Here, actually, it should be the source address, but it's none. None means I don't want to receive it anymore, actually. So as we said, it's a kind of leave message. And after receiving this, the router needs to ask for this group, for the group 228.1.1.2, is there any other receivers in my subnet? So it will send a group specific query. Says, is there anyone want to receive the packet from this group? If there is a reply, so router A will still forward the package to the subnet. But if there's no reply, this multicast group will be discarded. So since there is no reply, so router A deleted this multicast group information. And in this subnet connect to the router, there will not be any package from the multicast group 228.1.1.2 anymore. Okay, this is the working process of the IGMP version 3. And next, let's see another, which is IGMP snooping. Of course, for the routers, we use IGMP to maintain the member relationships. But between the router and the host, there could be a switch, right? Of course, we should use switches to offer the access ports for different hosts, right? But for the switch, when it receives multicast data, it will be broadcasted. Okay, so by default, once a switch receives a multicast packet, it will be flooded or broadcasted. It will cause problem, right? So no matter from which group, once the multicast packet is sent to the switch will flood it. Even you can see even host B is not the receiver of this multicast group. Okay. So to solve this problem, we should have a solution, which is IGMP snooping. IGMP snooping enables multicast data to be sent only to multicast receivers at layer 2 according to forwarding entries. Let's say, how does it work? Once the switch receives the report from the host, it will record it. For example, now, after receiving the report from host A, the switch generates a multicast MAC address table based on the received G1 membership report. You can see like this. And then after we'll forward it to the router. Router will maybe send the packets to the subnet, right? So router A starts to send the G data to the subnet. And after receiving the G data, you can see after receiving the G data, the switch will check these entries in its multicast MAC address table to find out the corresponding ports. Right? For example, after receiving it, after checking the multicast MAC address table, switch will find that the port is 1. So it will send out the packet out only through the port, which is 1. And in this case, host B, host C will not receive it anymore. It can solve the problem we are facing in this case. And for the IGMP, we have 2 different modes. It's IVGL and SVGL. In the IVGL mode, multicast streams of VLANs are independent of each other. A host can only request the multicast streams from a routing interface in the same VLAN as a host. While different from that, in the SVGL mode, hosts can request multicast streams across VLANs. Multicast data streams received from a multicast VLAN can be forwarded to hosts in other VLANs. Okay, so this is about the working principle of IGMP, which is running on the switches. And about this part, about IGMP and IGMP snooping, here are some questions. Let's see it. Firstly, which of the following packets are IGMP message packets? A, membership report. B, leaf group. C, general query. D, group specific query. So which of them do you think? Here, all of them are the IGMP message. Okay, and next, after detecting what packets on an interface, the switch adds the interface to multicast forwarding table. And after detecting what packets on an interface, switch deletes the information from the forwarding table. I think for the first part, which was the member report, member report is a kind of join message. And for the second part, after detecting what, the switch will delete the interface. Delete means don't want to receive anymore. So it will be leave group, which was C. So here we choose A and C. Okay, that's all for this part. And here's a summary. It says that IGMP is a protocol used to exchange information between hosts and routers. It uses 4 types of message packets as we have introduced. And they have their functions and application scenarios. IGMP snooping enables layer 2 switches to forward the multicast data only to ports connected to user hosts that desire to receive the multicast data, avoids affecting other users, and saves network bandwidth resources. Okay, so that's all for this part about IGMP and IGMP snooping. Thanks for your listening.